Okay, good afternoon, everyone. And today I will present for Professor Jian. And because he cannot join us this time due to his visa problems, so I will present this study. And this work was conducted by Ms. Qingman and Jian. It was mainly about cool wars and cool roofs. They want to know how the cool urban surfaces reduce air temperature in Sri Canyon. This presentation includes these four parts: introduction, method, results and discussion, and the conclusion. I will start from the background. Because the seminar is about the urban heat mitigation, you may know the background very well. And here I want to emphasize the impact of urbanization with the increasing population and which decrease which not only increase the urban temperature but also decrease the urban wind. The urban heat island also increase the frequency and the intensity of summer heat waves, which decrease the thermal comfort in urban area and increase the building cooling load in the same time. Then how to mitigate the urban heat island? Increase shading, increase the urban ventilation, increase water availability, planting trees. All of them have the potential to mitigate. In this study, they want to know how the cool surface mitigate the urban heat island, specifically the cool wall and the cool roof. The cool materials refers to the materials with high solar radiation reflectance and high emission, which allow them to absorb less short-wave radiation and emit more long-wave radiation. Many previous studies have shown that the cool materials can reduce the air temperature, but by how much? And most of them emphasize on cool roof only, while for high-rise buildings, the cool effect of cool roof is just not enough. So this study focused on both cool roofs and the cool walls. Particular attention was on the deep street canyon. The low-level building walls are sheltered from the direct solar radiation, thus applying cool materials at the low level of the building may be not necessary. They further investigate the partially cool-coated wall include about 25% cool wall and 50% cool wall in the upper level. Three different times were considered, including the 9 o'clock in the morning and the 12 in the noon and 3 o'clock in the afternoon. And they also investigate two Sri Canyon aspect ratio, a typical one with aspect ratio of 1 and a deep Sri Canyon with a very large aspect ratio of 5. They use the ANSYS fluent to simulate the wind and the temperature field in idealized 2D full-scale Sri Canyons. The computational domain is shown in the figure at the left side. The width of the Sri Canyon is about 24 meters, and the distance from the building roof to the domain top is about 120 meters. The turbulence was served by the standard Epsilon model in this study, and the radiation was served by P1 radiation model. The position is at Guangzhou, China, and the simulation time is at September, which is the autumn in China. And for the velocity domain, the inlet, they use the atmospheric boundary layer for the velocity and for the turbulent kinetic energy. And they use a very refined mesh, particularly in the near wall region. The minimum grid size near the building and the ground surface is set to about 0.1 meters because they want to capture the small variation near the walls. In total, 2 to 4 million grids were used in this very simple model. And this table lists the physical properties of buildings and ground materials applied in this study. The thermal properties are from the scaled outdoor experiment I will show you later. They mainly change the absorptivity of material to change access of solar radiation to the cool materials. So this part shows the results and of the simulation. There are contours of the in-canyon air temperature. In the case with aspect ratio of 1 at 9 o'clock in the morning, compared with the no cooling coating cases, the benchmark cases, the cooling when we cool materials at both the roof and wall, and the air temperature will decrease by zero point 0.4 to 0.8 degree, while when we only use cool roofs or cool walls, the cooling effect is very small, and when we combine them together, they are not as good as when we're cooling both walls and roofs in the same time. Sorry. And for the very deep street canyon with the aspect ratio of 5, it can be seen that the cool wall only decreases the surface temperature of the wall that directly heated by the solar radiation. But as the street canyon becomes deeper, the proportion of the area directly heated by the solar radiation is smaller. So they furtherly investigate the cooling effect of partially cool coated. That means only or very in the wall, some area is painted with cool materials, some are not. And we can find that compared with the no cool coating case, 50% cool coated wall and 25 cool coated wall both show a similar cooling effect on the in-canyon air temperature as in the entire cool coated wall. The figure shows that in Deep Street Canyon at 3 o'clock in the afternoon, the cool wall settings mainly cool down the window wall, and the partially coated, the 15 cool coated wall can achieve a similar cooling effect to the similar effect if we cool all the surface from the top to the ground level. Okay, here comes the conclusion. Uh, Coupling the cooling effect and the cool walls has better cooling effect than just cool roofs or cool walls individually. Cool roof can decrease the roof surface temperature by 3 to 5 degrees, but slightly decrease the near roof air temperature by zero point 0.1 to zero point 0.2 degrees. Cool wall mainly cool down the wall surface and the near wall air near around the area that directly heated by solar radiation. And the entire cool coated wall are not necessary in a very deep street canyon. Okay, that's the conclusion. They also conducted a reduced scale measurement to investigate the impact of cool coating on the outdoor air temperature. If you are interested in that study in the outdoor field measurements, you can find more details in this paper. I will pause 5 seconds here if you want to take a photo. And if you have any questions about that study, please contact Professor Hang Jian or the leading author, Mr. Mr. Mongyong. And that's all of my presentation. And if you have any questions, I will try my best to answer them. As I have said, this is not my study. And if you have any comments or suggestions, I will bring them back to the leading authors. Okay, thank you.
Thank you. Do we have any questions? Any questions? All right. Okay. If not, I think that conclude our. Thank you. I think that conclude our session today. And let's give another round of applause to all the speakers. Thank you. And also thanks to all our volunteers. All right. Thank you.